Hello, welcome to Soft Peppers channel. I am Godfrey. In this video, I'm dealing with Cambridge as physics. Topic is physical quantities and units. This is 2019 October-November exam series. I encourage you to consider doing your revision topic-wise. Read a given topic and come attempt the questions when the content of that topic is fresh in your mind. In this way, you will get the most out of the topic. This is a sure way of getting your A star, if that's your goal. If you have not already subscribed to my channel, please click the subscribe button and hit the bell icon below. This way you will be notified every time I upload a new video. If you find this video useful, I encourage you to share widely with your friends. They also get to benefit from the same. Let's get started, guys. This will be able to help you to know which question and from which paper was the question we are dealing with was set. This question number 1 was set in paper 1, and it was question number 1 of October-November 2019. That will be useful for you if you need to do any cross-checking, or if you want to confirm the answer from the marking scheme. Number 1, for which quantity is the magnitude a reasonable estimate? Magnitude a reasonable estimate. Of course, frequency of a radio wave, 500 picohertz. Of course, you know that pico is 10 raised to power minus 12, and so 500 picohertz. This is basically same as 500 times 10 raised to power minus 12 hertz, and this will give you approximately like 5.0 times 10 raised to power 12 minus 10, sorry, minus 10 hertz. Quite slow, quite low frequency. This cannot be frequency at all. So A is not right. What about B? Okay. Micro, this is 500 microgram. Micro is basically 10 raised to power minus 6. 10 raised to power minus 6. And therefore, 500 micro, 500 micro is 500 times 10 raised to power minus 6 grams. This is approximately 5 times 10 raised to power minus 4 grams. And this is not correct. An atom is much smaller, right? So it's not 10 raised to power minus 4. That cannot be correct. Young modulus of a metal, kilo is 10 raised to power 3, that is 1,000, and therefore 500 kilopascal is 10 raised to power minus 3, which is basically 5 times 10 raised to power 5 pascals, and Young modulus is usually in terms of 10 raised to power power 11. So if you get anything else less than 10 raised to power 11, then that is not correct. So this is also not correct. What about wavelength of green light? Nano is 10 raised to power 9. Nano is 10 raised to power 9. And therefore, 500 nanometer is the same as 500 times 10 raised to power minus 9, which is same as 5 times 10 raised to power minus 7 meters. And this is true. So our answer here is D. Question number 2. This was set. This was question number 2 of paper 1-1. The speed of a wave in a deep water depends on its wavelength, L. The speed of a wave in deep water depends on the wavelength, and the acceleration of free fall g. What is the possible equation for the speed of at the speed v of a wave? Okay, you know that the units of g is meters per second squared, and unit of L is in meters. Okay, so unit of speed, we know it's a unit of speed is meters per second squared. Is meters per second. Sorry, not squared. Meters per second. So let's look at air. Air, we are being told V is equals to square root of G L over 2 pi. Okay. Of course, here we know you remove the square root. So if you remove the square root, it will be V squared is equals to GL over 2 pi. And of course, we said that the units of G is meters per second squared times the units of L, which is meters. Yeah. So then this one will give us meters squared per second squared, and this is V squared. Of course, if you take V squared, the square root of V squared, both sides, then you'll get V is equals to meters per second, which happens to be right. So the answer here is you can confirm for the others. Like for example, let's do B. For B, let's do B to show you what you need to do. For B, V is equals to GL over 4 pi. Of course, 4 pi doesn't have units, so we are only dealing with B, and we know that the unit of G is meters per second squared. This one here, meters per second squared, and the unit of L is meters. So this will give us meters squared per second squared, which is V, and we know that the unit of V is meters per second, and therefore this is not right. So you can do the same for C and D, but of course, since you got this first answer as A, you don't need to waste time with the others. Time is precious, so you keep going. Of course, number 3, and as you get to number 3, I'll ask you to head to softpapers.co.uk to get this same paper I'm solving right now. And this is because you need to practice working out these questions yourself. It's good to watch my video, but my intention is to help you with this video to know how to solve these questions so that you can do them yourself. The site that I'm talking about here is this one, softpapers.co.uk. This is the site I'm talking about right here. It's a very resourceable site, rich with CIE material. I need you to come to A-level Physics 2019. You can also get papers for the others. 2019, there are past papers and topicals. Of course, we are in AS, so you go to topicals. You can also get past papers, but as I've indicated, topical revision is the best. I've done this with my student, it works every time. Of course, 2019 is has got both November and October topicals. What we are dealing with here is the physical quantity. This one here, physical quantities and units. So I need you to click this green button here. Of course, when you click this green button, it will bring you here. Of course, 2019, you can get soft papers for 2019, 2018, all the way to 2016. Or you can get all of them at a discount. But what you're dealing with here is physics. You can get for physics, chemistry, and mathematics. So November is here. You can also get for June, right? Of course, November is here. So I need you to click this to add to your cart. It's basically £10. You can request your parents to bail you on this. This is just a small price which you can easily afford, and you'll get all the papers for 2019, 19 November. You can also get for other years. Get as many as you can and make sure you work them out, and this will be a good way of making sure you get your A star. I also do online classes. If you need my assistance online, whichever part of the world you are in, I will be glad to help. I'll do online tuition at SP Academy, spacademy.co.uk. I charge a fair price of, if you are one student, one-on-one, my price, I'll charge you £35 per hour. If you come with 3 of your friends, so that you are 4 students, I'll give you a discounted price of £25 per hour. So try me. The site I'm talking about is this one here, SP Academy. It's a very resourceful site. Of course, currently we are handling ICT, mathematics, physics, biology, and chemistry. I do physics and chemistry. You can get in touch with me. Of course, I need you to first check the student guide here and watch this video to get familiar with what we do in this site. And of course, I need you to come here and register. Of course, create your own account. You'll access your own dashboard. We will send you an email. Use that email to activate your account, and then you can sign in here. Once you sign in and you get to your dashboard, then you can request a tuition from any tutor. My name is Godfrey. You can always get in touch with me, find a tutor, and then I will help you to get your A star. That's my business. I've done it for many other students. If it's your turn, I'll be glad to help you. So hopefully I'll be seeing you in my tuition class to help you with the journey to the best university in the world. Number 3, this question was set on paper 1-2, and it was question number 1. Cyclist has a speed of 5 meters per second, and a small car has a speed of 12 meters per second. Which statement does not give a reasonable estimate? Right? Does not give a reasonable estimate. The kinetic energy of a cyclist is this. All right. We will see that the kinetic energy of a cyclist is this. Of course, a cyclist, let's assume he has a mass of 60 kg. Let's assume a car has a mass of 1,000 kg. So based on that, you can calculate the kinetic energy of a cyclist. A kinetic energy is half mv squared. This is just an estimate. Remember, we're doing a reasonable estimate. Times 60, a cyclist, times the speed of a cyclist, which is 5 squared is 25. So basically this is 30, and 30 times that, you'll get 750 joules, and 750 joules is less than 1,000. This is 1,000. 1 times 10 raised to power this is approximately 1,000 joules, and of course the cyclist is got less than that, so that's not a reasonable estimate. What about kinetic energy of a car being this? This is the same as 7, then 4 zeros, joules. This is 7,000. No, this is 70,000. 70,000. Right, let's see. The kinetic energy of a car is a half. The mass of a car is 1,000, and the speed of this car is 12. Therefore, it is 144. This is basically going to give us, let's see, this is that, this is 500, and 500 times this, it will be 14400 times 5 is 0, 0, 0, carry 2, 2, carry 2, 7, right? 70,000. Yeah, this is same as this one, and actually this was also close to 1,000. This 750 is almost close to 1,000, so this is also correct. I said it wasn't correct on time. I was wrong, sorry. That is almost correct. This is 70 2,000 joules, which is almost close to 70. What about momentum of a cyclist? Is this? This is same as 400 kilogram per meters meters per second. So momentum is mass times velocity, and the mass of this cyclist, we have said, is around 60. Velocity is 5. Therefore 5 times 60 gives us 300, and 300 is close to 400. So that is also correct. D, momentum of a car is this. This is 2,0,0,0,0,0. This is 200,000 kilogram meter per second. Let's see. Momentum of a car, the mass of a car is 1,000, and the speed of the car is 1,200. 12 meters per second. So this gives us 12,000 meters per second. And this is way too large than this one. So this is not correct. We are looking for the statement which is not correct estimate. So the answer is D. That's how you work out this. Of course, you need to be very fast. Each one of these questions, I say that this paper is basically 1 hour and 15 minutes. 1 hour 15 minutes. These are basically 75 minutes. And 75 minutes divided by 40. This is approximately 1 minute and something, right? 1 minute, that is 125. 1 minute and 80 seconds. 1 minute and not 80 seconds. 1 minute. There's 35, and that's this would be basically, you need to spend 1 minute and a few seconds, like 10 seconds in every question. So you need to be very fast to be able to work that out. Otherwise you'll not be able to finish that paper. 40 questions. Number 4, which expression gives an SI Benz quantity? Charge per unit time. Okay, we know that charge is equals to current times time. Therefore charge per unit will give us a current. Current is equals to charge divided by time, right? So which expression gives the SI Benz quantity? That's correct. Let's see why B is not correct. Force per unit area. So force per unit area is pressure. Pressure is equals to force per unit area, and pressure is not a Benz quantity. We only have at least 7 Benz quantities. We have length is a Benz quantity, mass is a Benz quantity, time is a Benz quantity, temperature is a Benz quantity. What else? Electric current. Electric current is another Benz quantity. Right, we have luminous intensity, and which is the last one, amount of substance. These are the only Benz quantities that we have. 1, 2, 3, 4, 5, 6, 7. The rest are derived. The rest are not Benz. The rest are derived, like volume, area, pressure, force, energy, acceleration. All those are derived, and therefore pressure is not a Benz quantity. What about C? Mass per unit volume. Mass per unit volume is density. Mass per unit volume is density. So density is mass over volume, and density is not among this. It's not a Benz quantity. Work done per unit distance. Work done per unit distance. Is there a quantity like that? I doubt. We don't have work divided by distance. It doesn't give us anything. Let's see. Yeah, it gives us force, actually, because work done is force times distance. Therefore, when you divide by distance, D will cancel and you get force. And force is a derived quantity, is not a base unit quantity. So the answer right there is B, is A, sorry. Number 5. This was set paper 1, 2, number 3. Which list contains only scalar quantity? To do this one very fast, you just identify the vector quantities. Displacement is a vector quantity. There's no scalar quantity here. Potential, momentum is a vector quantity. Velocity is a vector quantity. So scalar quantities are only in B. We only have a few vector quantities. Vector quantities includes velocity, acceleration, momentum, displacement, force, and which other is this? Just those, and the rest are scalars. So you just eliminate the vector quantities and then you'll be left with scalars. Number 6. Number 6. Which quantity with its unit is correct? All right. Acceleration of a bicycle. The unit of acceleration is meters per second squared. So since we are given meters per second here, this is not correct. It's not correct. We are looking at the quantity and the unit, and that are correct. So the quantity here is acceleration. The unit here is meters per second, which is not correct. Electric current in a lamp. The quantity here is electric current. The unit is ampere per second, and that is not correct. The unit of electric current is basically ampere, capital A only. So B is not correct. Electric potential difference. This is voltage, and voltage we know is joules per coulomb. Volt, that is, let me just write voltage is energy of a charge, and therefore a volt is equals to joules per coulomb, and which is this one. So this is correct. Kinetic energy is not, the unit of kinetic energy is not Newton meter. It's actually is not Newton per meter. It's actually Newton meter, because 1 joule is the same as 1 Newton meter, not Newton per meter. So the correct answer there is C. Number 7. Number 7 was set on paper 1, 3, and this was question number 2. And which two units are not equivalent to each other? Newton meter, is it equivalent to kilogram meter squared per second squared? Okay, let's find out. Newton meter, Newton is basically kilogram meter per second squared times meter. Do they give us kilogram meter per? This is remember, force is equals to mass times acceleration. That's why we are getting kilogram from force and meter for this. All right. So this will give us kilogram meter squared per second squared, which is correct here, because we are looking for the one which is not. So Newton meter is the same as kilogram meter squared per second squared. Let's look at this other one, Newton second. Of course, this is the same as kilogram meter per second squared times second. Right. This gives us kilogram meter per second. This is right. Then joules per second, is it the same as kilogram meter squared per second cubed? Let's see that. Joules, remember, joules is the same as Newton meter, right? So joules per second, this is the same as Newton meter per second, which is the same as kilogram meter per second squared for Newton times meter times per second. Of course, this will be meter times meter will be meter squared. So this will be kilogram meter squared. Then this will be per second cubed, which is correct. So it appears the correct answer is D. Let's confirm that. Pascal and kilogram and that. Pascal is the same as Newton per meter squared. And Newton per meter squared, Newton is kilogram meter per second times meter squared. This will give us kilogram meter cubed. This is per meter squared, sorry. This is per meter squared, right? Newton per meter squared. So this will be kilogram per meter per second squared. So it is not this. This is not right, and it happens to be the correct answer because we are looking for the units which are not equivalent. So D is the right answer. Okay, that's it, guys. Thanks for keeping me company. I hope this video has been of help to you. Recommend it to your friends and let them also get assistant and know how to work out these questions. Get these papers, these topical question papers at solvepapers.co.uk. And if you need my help, you can know where to get me at spacademy.co.uk. Thanks a lot. Hope to see you in my next video. Cheers.